Hey everyone, welcome back to my channel. Today we are diving into one of the most important concepts in linear algebra, row echelon form and rank of a matrix. And we will see one real life example on it.
Let's start with row echelon form. A matrix is said to be in row echelon form if it satisfies these three conditions. So first is all non-zero rows must be above zero rows. Second condition is the first non-zero element, that is, we also call it as leading element or leading term of each row must be to the right of the leading term of above row. Third condition is all entries below leading entry or leading term are zeros. If a matrix follows these three conditions or satisfies these three conditions, we say that matrix is in low echelon form. Let's take an example. Let A be a matrix 1, 2, 4, 0, 1, 4, 0, 0, 2. Here, let's check our first condition. All non-zero rows are above zero rows. Okay, the first condition is satisfied. Now let's check the second condition. The leading terms, that is the first non-zero entry. Like here in R1, our leading term is 1. Okay, for R2, our leading term is this one. And for R3, our leading term is this 2. So let's check whether they are to the right side of the leading term of above row. So this one is to the right side of the leading term of above row. Here 2 is to the right side of this one. Means second condition is also satisfied. Now let's check the third condition. Here all the entries below leading terms are 0. See, like for this element or for this leading term, here this 0 and this is also 0. Means all the terms below leading term are 0. Also for the second leading term, here for the second row, the entries below leading term are 0. That means all the three conditions are satisfied. Therefore, we say A is row echelon form. Now let's take another matrix B. 1, 2, 4, 2, 0, 0, 1, 2, 0, 0, 0, 0. Here also, first condition, all non-zero rows are above zero row. When all the entries in a row are zeros, we say that a zero row. So this is zero row. Okay. So here all the non-zero rows are above zero rows. Okay, now let's check the second condition. Here, this one is the leading term or leading entry also, and the leading term or the leading entry for second row is to the right side of this leading term. That means second condition is also satisfied. Now let's check the third condition. All the entries below leading terms must be 0. So for this leading term, all the entries below leading term, that is leading 1, is 0, are 0. And here also the leading term is 1. So below leading entry, all elements are 0. That means A and B are in row echelon form. Now let's have another matrix, matrix C, which is equal to 0, 1, 4, 1, 3, 5. Now we can see that in first row our leading term is this one. So in second row the leading term should be at the right side, that is here, but the leading term for second row is in the left side of the leading term above matrix, above row. So this is not a row echelon form. Now let's start with rank of a matrix. So the rank of matrix is the maximum number of linearly dependent rows or columns in matrix. It tells us how much unique information the matrix holds. In simple words, we can say number of non-zero rows of a matrix in row echelon form. Okay, so let's try to find a rank of a matrix A, which is equal to 1, 2, 3, 2, 5, 7, 3, 6, 9. Okay, to find the rank of this matrix, we have to reduce matrix A to row echelon form. So, firstly, all non-zero rows should above the zero rows. Okay. Then, here 1 is a leading term or the leading entry. So, all the entries below leading entry should be 0. That means we have to make this 2 and 3 0 using some row operations. Like for second row, R2 tends to R2 minus 2R1 and R3 tends to R3 minus 3R1. So by these operations, we can make this 2 and this 3 0. So the matrix will be 1, 2, 3 since there is no change in first row. Now 2 minus 2 is 0. 5 minus 4, that is 5 minus 2 into 2, that is 4. So 5 minus 4 is 1. 7 minus 6 is 1. 3 minus 3 is 0. 6 minus 6 is 0. 9 minus 9 is 0. So we cannot reduce it more. So this is our row echelon form. Here 1 is the leading term. And for the second row also 1 is the leading term. All the entries below leading terms are 0. And all the non-zero rows are above 0 rows. So this is row echelon form. So according to the definition, the number of non-zero rows in a row echelon form is the rank of a matrix. Here R1 and R2 are non-zero rows and this row R3 is 0 row. So the rank of matrix is 2. That is number of non-zero rows. Now let's see one real life example. In a data, if some features are linearly dependent, or they add a new information or they don't add a new information, is nothing but a rank of a matrix. Now let's say I have data in which there are two columns of height in inches and height in centimeter. So basically, they don't add new information to the data. These both are basically the same thing. So that means rank is lower. Here, one column is multiple of another column.
So, rank of a matrix isn't just maths. It is how we understand the power of information in a system. So, if you found this video helpful, don't forget to like, subscribe and share.